Hello students, welcome you all to the video lecture on signals and system. Today we are going to find out the impulse response of the system described by the following difference equation. The difference equation is given by y of n minus 3, y of n minus 1 minus 4 y of n minus 2, which is equal to x of n plus 2 x of n minus 1. Since it is a discrete system, we can apply Z transform for the given equation and we can find out the impulse response. So, when we apply Z transform, we should know some formula, that is Z transform of y of n is y of z, and Z transform of y of n minus 1 is given by, so whenever it is minus 1, you just put z and in the power this value, that is the shifted value minus 1, and then for y of n again we can write it as y of z. So, small y will become capital Y, n will become z when you apply Z transform for y of n. Similarly, for y of n minus 1, the shifted value, that is minus 1, will come in the power of z. Apart from that, for y of n we have y of z. Similarly, Z transform of y of n minus 2. So, n minus 2 is z power minus 2, y of z. We can apply the Z transform for the input signal also. So, small x will become capital X, n will become capital Z. Similarly, Z transform of x of n minus 1. So, again here the value has been shifted for minus 1. So, just put z power minus 1, and for x of n it is x of z. So, you should know these formula before applying the Z transform for the given expression. So, let us apply the Z transform for the given expression. So, we will be getting for y of n, we will be getting y of z minus 3, for y of n minus 1 z power minus 1 y of z minus 4, for y of n minus 2 z power minus 2 y of z, which is equal to, for x of n it is x of z plus 2, for x of n minus 1 it is z power minus 1 x of z. So, once we have done that, we have to simplify this term and we have to find out the impulse response. So, first of all, what is impulse response? Impulse response is denoted by h of n. So, when we will be getting the h of n? So, when we have a system, if we apply the input signal as del of n, that is impulse signal, if we apply, the output what we obtain is nothing but impulse response. Okay. So, here we are considering that input is nothing but del of n. So, x of n value is del of n. So, x of n equal to del of n. We have to consider x of n as del of n whenever we are finding out the impulse response. So, when we apply Z transform for this, we will get x of z is equal to Z transform of del of n. Z transform of del of n is nothing but 1. So, wherever we have x of z, we have to replace it as 1. So, in the problem when they ask to find out the impulse response, we have to substitute x of z as 1. So, that you have to know. And then, so to find out the impulse response h of n, we have to first find out what is h of z, that is the transfer function h of z. Why? Because h of z is given by y of z by x of z. When we apply inverse Z transform for this term, that is Z inverse of h of z is nothing but h of n. So, that we can find out the impulse response h of n. Okay. So, first let me determine h of z, that is nothing but y of z by x of z. So, in order to find out x of z, let me take y of z commonly in the left hand side. So, that 1 minus 3 z inverse minus 4 z power minus 2, which is equal to, take x of z commonly in the right hand side, 1 plus 2 z inverse. Okay. So, we need to find out the transfer function, which is also called as system function. So, once we have determined h of z, then we can apply inverse Z transform and we can find out h of n. So, first we are finding out the h of z. h of z is y of z by x of z, which is nothing but 1 plus 2 z inverse divided by this term 1 minus 3 z inverse minus 4 z power minus 2. So, you are taking x of z alone to the left hand side. So, the numerator part remains as it is. This side numerator part which comes to the denominator. So once you have obtained this, now all the terms are in inverse z. So let us convert that into positive power of z. So whichever is the higher power term, so you have to multiply the opposite term for that. That is here z power minus 2. So let us multiply numerator and denominator by z square. Okay. So because we are going to convert this term into positive power of z. Suppose if we have z power minus 3 in the denominator as a higher power term, then we will multiply numerator and denominator by z cube. Okay. So here it is z power minus 2. So multiply numerator and denominator by z square. So when you multiply z square into 1, it is z square plus 2. Z inverse into z square is just z. Denominator z square into 1 is z square minus 3, z inverse into z square is z minus 4, z power minus 2 into z square will become cancel, that is 1. Okay. So now this is your h of z. So z square plus 2ez divided by z square minus 3ez minus 4. This is my h of z. Okay. So h of z is z square plus 2z divided by z square minus 3z minus 4. Okay. So actually h of z is given by what? Y of z by x of z. Let me write that. So h of z is not y of z by x of z, which is nothing but this term. Okay. And already we have determined that we have considered x of n as what? Del of n because of impulse response. So x of z is 1. So wherever we have x of z, we have to replace it as 1. So we are going to replace it as 1. So what happens? Whatever h of z, it is equal to y of z. So nothing to change in that equation. So we will be getting z square plus 2z divided by z square minus 3z minus 4. So now we have to apply the inverse z transform and we can find out h of n. So again, before applying the inverse z transform, always we have to take one z to the left hand side and then only we have to apply the partial fraction. So we have to remember that step. So take z commonly in the numerator. So what happened? So first term it will be of z, second term it will be of just 2. I am taking z in the numerator as a common term. So I will be getting z plus 2 divided by, let me factorize the denominator. So minus 4 I have. Okay. So when we multiply we should get minus 4, when we add we should get minus 3. So minus 4 plus 1. So minus 4 into 1 is minus 4 and then minus 4 plus 1 is nothing but minus 3. Okay. So these are all the factors. So how I can write? Z minus 4 into z plus 1. Okay. So the denominator term, the quadratic equation, I can split as this factors, z minus 4 into z plus 1. So now I have to take one z to the left hand side and then we have to proceed. Okay. Since h of z equal to y of z, let me leave y of z. I will consider this as h of z itself. Take one z to the left hand side. So if you do not have any common term or z in the numerator, you just divide by z in both left hand side and right hand side. Our aim is to find out the left hand side term divided by z, that is all. Okay. Here it is h of z, so divide that term by z. Here actually we have z in the numerator, so we are taking that to the left hand side. Else in general what we can do, in the left hand side and right hand side just divide by z, that is all. Okay. So take one z to the left hand side. So what happened? We have z plus 2 divided by z minus 4 into z plus 1. So apply the partial fraction. So a by z minus 4 plus b by z plus 1. Okay. So left hand side is what? Z plus 2, which is equal to a into. So compare the denominator with the denominator whatever available in the a. Okay. So here z minus 4 is already available. So which term I have to multiply? Only z plus 1. Similarly for b, compare this denominator term with this term. Already z plus 1 is available. So which is not there? Z minus 4 is not there. Just multiply. So I have to find out a value and b value. So substitute the opposite sign value, that is z plus 1 equal to 0 I have to substitute, so that I can find out z equal to minus 1. So, substitute the value such that this term and this term get cancelled, so that I can find out the a and b value. So, let z equal to minus 1, similarly let z equal to 4. Okay. So, when you substitute z equal to minus 1, here minus 1 plus 2 is what? 1, and here this term get cancelled. So, I can determine only the b term. B term minus 1 minus 4 is what? Minus 5. So, b equal to minus 1 by 5. Similarly, substitute z equal to 4. 4 plus 2 is 6. Okay, here 4 plus 1 is 5. So, 5a. So, this term get cancelled. A equal to 6 by 5. So, once we have determined the a value, b value, let us substitute in the h of z. Okay. So, h of z is given by, h of z is 6 by 5 divided by z minus 4 minus 1 by 5 divided by z plus 1. Take z to the right hand side now, because we are going to find out h of z. So, 6 by 5 is constant, z by z minus 4 minus 1 by 5 is constant, take z to the right hand side. So, z by z plus 1. Okay. So, now apply inverse z transform for the whole term. Okay. So, we know that z inverse of z by z minus a is what? A power n u of n. Similarly, z inverse of z by z plus a is minus a the whole power n u of. So, using this concept, okay, let me apply inverse z transform. So, what happens? H of z will become h of n, which is equal to 6 by 5. Inverse z transform of z by z minus 4 is what? 4 power n u of n. So, instead of a I have 4 here. So, 4 power n u of n minus 1 by 5 z by z plus 1. Okay. So, it is minus 1 the whole power n u of n. Okay. So, this is the impulse response for the given difference equation. Okay. So, 6 by 5 4 power n u of n minus 1 by 5 minus 1 the whole power n u of n. Okay. That is all. Thank you. Thanks for watching.